Electricians, let me walk you through a licensing exam question you very well might see on your licensing exam, but it's from our book, A Comprehensive Guide to Passing the Electrical Licensing Exam. Our question reads, what size inverse time circuit breaker should be installed for a group installation to protect the following 208-volt three-phase motors? There's one 7.5 horsepower, two 10 horsepowers, and one 15 horsepower. The first thing that I'm going to do in accordance with our NEC navigation method, again, that we teach in our book, A Comprehensive Guide, is write down keywords. I try to write these down in order of importance, and I'll show you what I mean by that in a second. So the first one I wrote down is motors. The second one I'm going to write down is inverse time circuit breaker. The third one I'm going to write down is group installation. Okay, I'm spelling that one wrong. Oh boy, let's try that again. Okay, the next one is 208-volt three-phase. Okay, if you're doing this on your licensing exam, feel free to write this down on a sheet of paper, but I promise you, if you're doing this navigation method often, you're going to be able to do it without writing anything down. You're going to be able to do it in your head, and it's going to be a lot quicker than however long this video is going to be. So 208-volt three-phase motors, and now I'm going to write down the individual motors that we have. Okay, so there's one 7.5 horsepower motor. The next one is two 10 horsepower motors. And the next one would be one 15 horsepower. Now that I have my keywords, now I'm going to get out my codebook and I'm going to navigate the codebook and find the answer. Okay, the reason why I said in order of importance, okay, my first keyword is motors, and because I study flashcards, which I highly recommend to write your own flashcards and memorize certain code articles, certain tables, certain topics, because I've studied, I know to go to Article 430, which talks about motors, okay? I have this camera so you can follow along with me. I will zoom in if I have to when we start getting specific, okay? So 430 is a pretty large code article, and I don't have to waste any time going to the index and table of contents. I know, based on my keywords, I'm going to Article 430. If you're interested, we have our own flashcards that we sell, again, with the code articles that we recommend you having memorized, but a big mistake that many electricians do is they'll get to the code article and then they'll start reading in hopes to find the answer. That's also a mistake, okay? We just narrowed down this entire code book to one code article. Let's do that again. Let's narrow down this entire code article to a specific part number, okay? So part 1 is general. Part 2 is somewhere. Part 2 is motor circuit conductors. You probably can't read that right now, and that's okay. I mean, I can zoom in a little bit, can I? Part 2 is motor circuit conductors. Are we sizing motor circuit conductors? No, we're not. So we're going to continue until we see part 3, motor and branch circuit overloads. Are we sizing overloads? No, we are not. Therefore, let's move on to part 4 is down here, motor branch circuit, short circuit, and ground fault protection, okay? So I know the question doesn't specify that it's motor, branch circuit, short circuit, and ground fault, but that's what an inverse time circuit breaker does, right? So because we're sizing an inverse time circuit breaker, I've narrowed down Article 430 down to part 4. Now that I'm here, I'm only going to look at the bold headings, okay? We're going to continue narrowing it down, because if you start reading, I promise you're going to read information that you don't need to know, okay? So I know that my answer is probably not going to be in 430.51 general, right? So let's continue until I see the next bold heading. Rating or setting for individual motor circuit. Are we sizing an individual motor circuit? No, right? So I can skip the A's, B's, C's, 1s, 2s, and 3s, right? So let's skip all of that until we see the next bold heading with a number next to it, right? So 430.53 says several motors or loads on one branch circuit. Now that sounds like we're in accordance with our question. But again, let's continue reading the A's, B's, C's, 1s, 2s, 3s now. Okay, A says not over 1 horsepower. Okay, we're over 1 horsepower, so we're skipping A entirely. Let's go to B, make sure you can see it. If smallest rated motor protected, okay? It doesn't say our smallest motor is protected, okay? And C says other group installations. Now we're hitting it, okay? So now it says 2 or more motors of any size or 1 or more motors and other loads with each motor having individual overload protection shall be permitted to be connected to a branch circuit where the motor controllers and overload devices comply with C1 through 5. Okay, so now we have to comply with 1 through 5. So 1 says type of assemblies, okay? The question doesn't say the assembly type, so I'm pretty sure I can skip 1. 2 says motor overloads, again, doesn't say anything about motor overloads. 3 says motor controllers, again, nothing about controllers in this question. And 4, which you can't see, which is down here. 4 says short circuit and ground fault protection. Again, that's what an inverse time circuit breaker is for motors. The branch circuit shall be protected by fuses or listed inverse time circuit breakers having a rating not exceeding the sum of all of the following. Okay, so we have numbers down here, 1, 2, and 3, and it's going to give us an ampacity for each one. We're going to get those ampacities and we're going to add them together in accordance with this code. So 1 says the value specified in 430.52. So it's telling us to go to a different code article for the highest rated motor connected to that branch circuit. So we have to figure out which one of these is the highest rated motor. Most likely it's going to be the highest horsepower motor, especially since they're the same phase and voltage, right? It's probably going to be the 15 horsepower. But again, we have to get the value based on 430.52. Okay, so this is another lesson, but it's foundational in how we size motors. Okay, if you don't understand this code, you're going to get a lot of questions wrong on your licensing exam. And that code I'm talking about is Article 430.6. So let me go there and I will show you how to size all motors, okay? So 430.6 is right here. It says conductor ampacity and motor rating determination. How do we determine which ampacity to use when sizing motors? A says general motor applications. 1 says table values. What table is it talking about? It's talking about these tables here. 430.247, 248, 249, and 250. So in the back of this code article, Article 430, there's tables that give you ampacities for specific motors, right? 3-phase, 208 volt, 240 volt, whatever it is. They're going to give you an ampacity. However, each motor has an ampacity written on its nameplate. Okay, sometimes the question will give you the ampacity. If it gives you the ampacity, that's the nameplate, okay? But do we always use the nameplate? No, sometimes we use the ampacity written on the tables. So again, when do we determine, or how do we determine which ampacity to use? And this tells us. Other than for motors built for low speeds, high torques, canned pumps, or multi-speed motors, okay? If the question specifies a very specific motor, then we're gonna do something different. But when it doesn't, the values, the ampacities given in the tables in the back of the code book or code article shall be used instead of the actual current rating marked on the motor nameplate to determine the following, okay? Ampacity of conductors, current ratings of switches, current ratings of branch circuit, short circuit, and ground fault protection, okay? So in other words, the only time we use the nameplate ampacity is when we're sizing specific motors, again, like high torque, canned pumps, right? Those are specific motors, or motor overloads. For everything else, we're going to use the ampacities in the back of this code article. So that's where I'm gonna go now. I'm gonna figure out based on the motors in question, which one is the largest based on the ampacities given in the back of this code article, okay? So article, it looks like 430.250 gives us the full load currents for 3-phase AC motors. So that's what they're giving us in this question, right? 3-phase, 208 volt. So now we're in 208 volt. And our first motor is 7.5 horsepower. So what's the ampacity? We're gonna go like this, 24.2 amps, okay? So let's go to this one. And what did I say? 24.2 amps, okay? Our next one is 208 volts, 10 horsepower, which is 30.8. Let me write that down. So 30.8 amps. And then the last one is a 15 horsepower. So 15 208 volt is 46.2 amps. Now I have those ampacities. Now I can go back to that code article and figure out what it was telling me to do, right? So how do I do this? 430. So again, let's go back to this code article. It says the value specified in 430.52. So let's go to 430.52, and here's this table, okay? Now, it tells us the maximum rating or setting for the motor, branch circuit, short circuit, and ground fault device, okay? So we got the ampacity. Our highest rated motor is that 115 horsepower, 46.2, but I have to take that 46.2 and multiply it by 2.5. I have to get a calculator out now. Let's do this, 46.2 times 2.5 gives us 115.5. Okay, so is it based on the circuit breaker or the value determined, right? So let's go here. and it says the value specified in 430.52 for the highest rated motor connected to that branch circuit. Okay, so it's not the size of the breaker. Remember, there's no such thing as a 115.5 amp breaker. So 115.5 is the value specified in 430.52. So we have the ampacity for number 1. 2 says the sum of the full load current ratings of all other motors, okay? So now I need to take that 115.5 and I need to add the remaining ampacities of those motors, okay? So which I wrote down, right? 24.2, 30.8. So I'm gonna take my 115.5 and I'm gonna add 24.2 and I'm gonna add 30.8, but I need to make sure that I do that twice because there's 2 10 horsepower motors, right? Plus 30.8. So my ampacity is 201.3, but again, there is no such thing as a 201.3 amp breaker, right? So let's read this again. The branch circuit shall be protected by fuses or listed inverse time circuit breakers having a rating not exceeding the sum. So what's the sum? 201.3 is the sum, but I can't exceed that number, right? So I have to go down to the next sides, which it's just gonna be a 200 amp breaker. But if you're not sure, we're gonna go to Article 240.6a, and it gives us the standard ampere ratings for fuses and inverse time circuit breakers. And again, 201.3, there's no such thing. So we have to go down to 200 because this specific code said shall not exceed that amount. So now let me get my book, and we're gonna see if we have the correct answer here, okay? So again, here's our question. Let me zoom out now. Here's my question. I'm gonna flip the page and it's gonna tell us the correct answer. 200 amps is our correct answer. Hopefully that was a good walkthrough for you guys to fully understand. Hopefully you understood everything that's going on the screen. Comment down below if you have any questions, if you need more walkthroughs, if you have any other suggestions for other types of videos that you would like to see. But this is a walkthrough. We're dedicated to helping electricians study for and pass their electrical licensing exam. So thanks guys, we'll see you on the next one.